Okay, I'm going to talk to you just a little bit about format. So you've seen this, I think, in some of your booklet stuff already. So this means the change of y with respect to the change of x. So that's slope, right? When we talk about how does y change to the ratio of how does x change, right? That's what y2 minus y1 over x2 minus x1. That's an idea. So this is what it means, the change of y with respect to the change in x. Okay? Sorry, what's that? The change of y with respect to the change of x. Yeah. So what do you think about with slope when you think about slope? What is slope doing? This is talking about the change of the heights over the change of the x. That's exactly what it's doing. Does that make sense? Because whenever we talk about functions, we always are comparing it to x. Like, what is y doing if x is this, right? It's always comparing it with the x. Okay, so this little symbol stuff, we have just been doing a little bit of a shortcut, y prime. Okay, so that's what we've been doing. Okay, so today we're going to activate also, when we talk about deriving x, when we talk about deriving with x, we would change x with respect to x, because we always do everything with respect to x, because that's what functions are all about. I don't write anything. When I derive x, this is just 1. Okay, so I really just don't write anything. So when I derive y, I have to consider it, but when I derive x, I'm considering it, but I just don't write it, because it's just 1. Okay. So that's the gist of kind of just a bunch of these notes that I wrote there. So you can see me doing dy over dx. Okay? So that's all that stuff there. Okay, here we go. So if I derive this equation, here's what we're going to do. We're going to derive. So what's the derivative of x squared? 2x. Okay? I'm going to attach it now, but we don't need to do it. And then I did that derivative of x with respect to x. Okay, but you can see that I don't need to even attach that, right? We've talked about that. Plus, how do you derive? So this would be 2y, 1 lower. And what did I do? I derived that letter with respect to x. And then what's the derivative of 25? 0. Okay, so here's what we did. We said, forget that. It doesn't even need to be written. And we also said, well, let's just kind of write this as a y prime. So what is y prime? How do you isolate that? How do you get the algebra out of that? We are going to have to move that unit over, right? This is like, remember when we did the log stuff? That's kind of like the same algebra behind that one. And then divide. What's that? Did I draw these boxes at the top? Yeah, because I wanted to do it in there, but.
Oh, I see.
Okay, so I'm going to show you how to do this in another way. This is the way I want you to do it. I'm just going to show you a proof why it works in another way. Let's make an equation of y equals here. So how do you get y equals? We're going to move over and we're going to square root. Okay, ready? Let's rewrite this. I'm just going to actually take the positive right now. Let's rewrite the root as a 1/2 instead. Okay, derive this. So you're going to get 1/2 of those units, 1/2 of those units to the negative 1/2, right? Times the derivative of the unit. Okay, can I go like this? The 1/2 times 2, is that okay? Okay, so these are the same answers. This one has us containing both letters, and this one has us only containing x numbers. Okay, that's just the difference in what we did. Because y is the square root of this. That is the same as a y. Okay? So did you know that this year you're going to learn how to graph those? You get to learn that this year in advanced math. So this is a circle. It's actually very easy. The center is 0, 0, and then the radius is 5. That's what this is, an R of 5. So here's what we can think about. Where do you want to pick a spot to be a tangent line? Something like at x of 1. So if x equals 1, here's my tangent line. The slope formula is negative x over y. So negative 1 over and then y. So if x is 1, 1 squared, so that'd be the square root of 24. Would that make sense? Does your line look like it's going on a slope of negative 0.2? Okay, so this is what it's all about. Okay, you don't have to be doing this, but I'm trying to get you some visuals so you can make connections about like why are we doing this, what's going on. Okay, so here's what you're going to really be doing. Okay, here we go, deriving. So we're going to go 3x squared is the derivative of that. Attach the derivative dx over dx, which I'm not going to write. Plus derive that. 12y cubed, attach the derivative of the variable, and this time I'm going to write y prime. Plus, derive is 3y squared, and attach the derivative of the variable. So y prime equals derivative of 5, 0. Okay, how do you algebraically get this? Okay, so I'm going to keep this unit and keep this unit because they both have y primes in them. So I'm going to move that out. Do you remember us doing this kind of thing with logs? Right? If it had logs in it, you keep it. If it doesn't, move it. I need you to GCF a y prime out. Y prime out. Let's see. Okay, so you've seen this algebra before. Okay, one more and it's a little bit harder now. Okay, here we go. Derivative of this is 2x. If I do the variable, it's a dx over dx. Don't have to write. The derivative of this is 3y squared. If I attach, it's a dy over dx, which I have to write, but I'm doing the shortcut. Uh-oh, something complicated there. What are we going to do? Anybody have a suggestion? What do you think I'm going to have to activate with all that together? The product law. Product law. So how do we derive, if I separate that with this and this, so if I'm kind of like the F and the G, remember? How do you do the product of two things? We derive this and keep that. Remember the rules? Derive that, keep that, plus, what do you do? Keep that, derive this, but as soon as you derive something with a y, you attach a y prime. And then the derivative of 6 is 0. Okay, let's talk about what has y primes in it. That one does, and that unit does. So those are going to stay. So 3y squared y prime. And can you see I'm going to put those 2 and 4 together in that unit? There's a 2 and there's a 4. So 8x squared y prime. Okay, now that you have all the y prime stuff together, you can GCF it out. Okay, I think I just want to do a really short one here. Just the product law again here. Just one little product law. We'll do it one more time. Just if you had, again, a product law going on. Let's try it. So I'm going to treat this and this as my two items. Product law, two items. Okay, ready? Derive. So 20x cubed. And then I'm deriving with x, so I don't have to do any attachments. Derive times the keep. I derive keep plus keep derive, so 3y squared, but as soon as you derive y, there's an attachment. Okay? So if you derive something with the x, you don't have to attach anything. Derive y, you attach. Does that seem okay? That'd be the most tricky part of it right there, a product. Okay, are you good with the algebra? It's very similar to our logs unit when we did a bunch of that stuff.